So we're starting by solving quadratics here. In order to solve a quadratic, the first thing we always want to do is we want to get the x squared part by itself. So in this case, notice that means getting rid of the minus 1. So in order to get rid of the minus 1, we add 1 to both sides. Doing so gives us x squared equals 9. Make sure you have that down in your paper before we go forward from there. We now know that x squared equals 9. Now you could look at this and you could kind of figure out, okay, well I know what number squared equals 9. What is that number?
3.
3, absolutely. But what are we actually doing? Mathematically, what are we doing to the equation in order to do that? What undoes a square? What's the opposite of squaring something? Square root, yeah. We're actually taking the square root of both sides. And so that's where we get the 3, because the square root of 9 is 3. Because remember, square root just means what number times itself equals that. Or in other words, what number squared equals that. So we end up with x equals 3. Now it seems fairly simple and straightforward, but there is one little wrinkle that we're going to have to include in this problem process, in the process of solving a quadratic. But before I tell you what that wrinkle is, I want to show you what it looks like. So on your graphing grids, above your first one, I'm going to have you write both of these equations and go ahead and graph both of these on the same set of axes. In order to graph these, I'm going to start by graphing f of x. So in f of x, notice we got the minus 1 hanging on the end there. Remember, anytime we have that number hanging on the end, that represents graphically it being moved up or down. So the first point that we put on there is down at 0, negative 1, because it's just shifted down 1. From there, it's a plain old x squared graph. We aren't stretching it or anything like that. So what is 1 squared? 1, right? So we go over 1 up 1. What about when we go over 2? What's 2 squared? 4. So we go over 2 up 4. What if we go over 3? How far up should we go? 9. Because 3 squared is 9. And if we went over 4, that would be 16, but that's off our graphing grid here, so go ahead and draw the curve in at that point. So that's now f of x graphed. In order to solve this, we have to graph both of the equations, though, so we now need to graph g of x equals 8. G of x equals 8, remember that was the same as y equals 8? So if you don't remember what the graph looked like, start by plotting a point where y equals 8. Now when I say that, most people think of that point right there. They think of 0, 8. But of course it doesn't have to be 0, 8. X can be anything. X could be 1, so it could be 1, 8. X could be 2, so it would be 2, 8. It could be anything in there. And so our graph of g of x is a horizontal line. Now, the equation that we started class solving, it was x squared minus 1 equals 8. The solutions here that we just found, the points where they crossed, should be the solutions for that equation as well. But notice that when we did it on the graph, we got 2 answers. When we did it algebraically, we only got 1. The algebra told us this number right here. It told us the positive 3. But it didn't tell us about this negative 3. That's the wrinkle that we're going to have, that we're going to need to go back and include in the algebra here. Because a parabola goes down and then back up again like this, it can intersect a line twice. And so we'll often have 2 solutions when solving one of these. When doing the algebra, that means we actually need to find both the positive and the negative square root of it. The way that that actually looks is that we write a plus or minus symbol in front of the square root. That plus or minus symbol means it's one where it's positive and one where it's negative. So when you see plus or minus 3 there, what that really means is 3 and negative 3. So this is then how the algebra needs to look to be completely correct. So go back to the algebra problem that we started class with, put that plus or minus into the work, and add the extra lines. And as you're doing that, again, the whole idea behind this is that when we take the square root of both sides of the equation, we have to account for both the positive and the negative. The whole reason is because if you square a negative, it gives you a positive, just like squaring the positive does. So now we're going to practice that idea of solving a quadratic. So here's a slightly different but same kind of equation. Go ahead and solve this equation out on your own, and then we'll go through it together to make sure you're on the right track. First step when solving this one, we want to get the x squared by itself, so that means getting rid of the 3. Since it's currently 3 times x squared, we divide by 3. That gives us x squared equals 4. Now that we have the x squared by itself, that's what tells us to do the square root of both sides. The big thing I want you looking in your work for, make sure you included that plus or minus. Because, of course, that's the big idea from today, is making sure that we include the plus or minus anytime we square root both sides of the equation. And so then we end up doing the square root of x squared, which is just x, because square roots and squares cancel each other out. And then the square root of 4 is 2. So we got x equals plus or minus 2 here. It is valid to leave it in this form. So this does mean 2 and negative 2, but it's slightly better form to write them out separately. So while both of those last two lines would be fine for a final answer, generally speaking, writing it as x equals 2 and negative 2 is a little bit cleaner, easier to see, easier to read. So I would tend to prefer that as a way to format your answer. Let's add one more layer of complexity to solving these equations. Still, you know how to solve these, you got all the pieces, but it's just a matter of being able to deal with a little bit more going on at once. Go ahead and solve this one out on your paper. So step 1 when solving this, get rid of the addition subtraction. So start by subtracting 7 from both sides. When you do that, we got 5x squared equals 45. From here, it looks a lot like that last problem we just did. So we got to get rid of the 5, divide both sides by that 5, and we have x squared equals 9. This is where we then are going to get rid of the squared, so we're going to square root. Remember that we include the plus or minus when we square root. The square rooting is what causes the plus or minus to occur, so that is the instant when you include it. And so then we end up with x equals plus or minus 3, or in other words, x equals 3 and negative 3, just to write it a little bit more nicely. So in this last problem, we're going to do it both by graphing and by doing the algebra, because again, I want to bring in why it works the way it does. I'm actually going to have you start by doing the graphing this time. So please solve this system by graphing. In other words, graph both of them on the same set of axes. So for f of x, in order to graph that one, we start with the shift up and down. In this case, it's being shifted down 7. So first point down at negative 7. From there, though, we got to look in the little details. Normally, I'd be going over 1, up 1. But in this case, I'm not going to go over 1, up 1 because we have the 2 in front of the x squared. That 2, remember, represents a vertical stretch. So instead of going over 1, up 1, we're going to go over 1 and up 2. It's a vertical stretch, so it only changes how far we go up and down. All right, then from there, normally, we're always thinking about what we normally would do first. Normally, I'd go over 2 and up 4. But in this case, I'm not going to go over 2 up 4 because I have that 2 out in front. I'm going to go over 2 and up 8. Because again, we're doubling how far up we go. Now what if I went over 3? If I went over 3, I'd normally go up 9. 9 times 2 is 18, so I'd go over 3 up 18, which is just off my graphing grid here. So I'm not going to plot that point. That means I can go ahead and draw the graph in. As you draw that curve in, though, remember that that next point was going to be like just up here someplace. Draw the curve so that you're kind of envisioning where it would be hitting if our grid actually extended out that far. You don't want to end up with something where you draw your curve in, and then, okay, I got to the last point. It doesn't exactly go way off like that, right? We envision where it would be going with that next point.
Bless you.
All right, and then we go on to graphing g of x. In graphing g of x, again, it's how far it's been shifted up or down. So in this case, it's been shifted down 3 for our first point. But this one's not been stretched at all. So I will go over 1 up 1, over 2 up 4, over 3 up 9, etc. All right, and then we have both of our graphs. We have f of x and g of x. Now notice what we're trying to solve here. We're trying to figure out, where does f of x equal g of x? That just means figure out where they intersect. So we have, again, 2 points where they intersect. You're noticing, hopefully, that this is happening a lot when we're dealing with quadratics like that. So I end up with those 2 points. So where are those 2? We got one of them that's at -2, 1, and we got the other point that is at 2, 1. On your graph, label those 2 points, because we're going to come back to those numbers here in a couple minutes. But label those 2 points on your graph there to show that those are the solutions. Having solved it graphically, we now can actually solve it algebraically. And so I want to connect the 2 for you. So having done it graphically, I'm now going to walk you through that process, at least the first step, algebraically. Then we're going to see how they're connected. So write down this equation if you haven't yet. All right. So in solving this out now, the very first thing I like to do, there are multiple ways to start, but the first thing I like to do is to move the x's together. And when I move those x's together, I always like to keep it a positive number as a result. So that tells me that I'm moving one of these 2 terms. But between those 2, only moving the x squared will end up resulting in a positive x squared left behind. So I'm going to start by subtracting x squared from both sides of the equation here. When we do that, that gives us x squared minus 7 equals a -3. Now it actually looks very familiar, I hope. Now it looks like something that you're used to solving, because it's like what we solved earlier in class. So go ahead and now solve that out. Figure out what x equals in this one. All right, so we now are going to need to get the x squared by itself still. So that means getting rid of the -7 by adding 7 to both sides. We now have x squared equals 4. Get rid of the squared by square rooting. And again, check your paper. This is the point where I expect to see that plus or minus in there. Did you include it at that point? And then we go ahead and do the square root. The plus or minus is just carrying down. That's why we have the plus or minus in front of the 2. Therefore, x equals 2 and -2. Now, we got our answer here. Let's go back and take a look at the graph that you made earlier. Because remember, we first solved this system by graphing it, or this equation, in this case, the way we wrote it for this one. When we did it graphically, we got 2 answers. We got -2, 1, and we got 2, 1. Now writing those on your graph. Now notice how those correlate to what we just found. We found here that x equals 2 and -2. The algebra, when we solve it out like this, it's telling us the 2 x coordinates. Now we could plug that back in to find the y coordinates, but solving it, we generally are looking to figure out just what the x value is. So it's different ways of getting the same information, but one is maybe a little bit better in some ways than the other. If all you're interested in, or I can speak, is what the x values equal, certainly the algebraic process is going to be a little bit more succinct. But if you need the coordinates for both points, both the x and the y, graphing it might be a little bit more efficient. So you always got to look at what it is that you're starting with and what you're dealing with. For now, though, you're going to get practice on both.